We're going to be treating this challenging exercise from the textbook. So, in a microcomputer, the address of memory locations are binary numbers. Identify each memory circuit where a byte is stored. This is just saying that in each memory location, let's say this is a memory location, this is a memory location, this is a memory location, it's represented by a binary number. So, this could be represented by 000, 0001, 0010. It's just saying each memory location is identified with a binary number. That's just what the question is saying. So now the number of bits that make up an address depends on how many different memory locations there are. This is saying so if you have 16 different memory locations to store, right? How many bits would you need? 2 raised power 4 is 16. You're going to need 4 bits. If you have 256 different memory locations, you're going to need 2 raised power 8, 256. You're going to need an 8-bit address. So that's what this second line is saying. The number of bits depend on the number of memory locations you need to save. Now, the last line, since the number of bits can be very large, the addresses can often be specified in hex instead of binary. I want us to take a look at this table here. You notice that to represent four binary numbers, you just need one hex digit. This is this is a much simpler form for really, really long binary numbers. So we're going to get back to this table again. So now the first question, if a microcomputer uses a 20-bit address, how many different memory locations are there? Okay, let's look at this question. So this is for A. A 20-bit address means 20 numbers in one binary no binary value. So 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. This is just one 20-bit address, one 20-bit address. Then to write another one, actually starts from 0. You write 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. You keep going till you reach 1111, 1111, 1111, 1111. This is the highest for a 20-bit address. So you notice there are 20 values here. That's just what a 20-bit address means. Now, now, to know how many different memory locations that can be stored with this 20-bit address, this will be the first memory location, this is the second memory location, this will be like going up to n memory locations. We obviously cannot be writing each memory location to know how many different memory locations can be stored. So there's a much easier way to do this rather than counting it manually. All you have to do is just 2 raised to the power of 20. And if you punch your calculator, you're going to get 1,048,576 different memory locations. So that means you can store 1,448,576 different memory locations if you're using a 20-bit address. That's number one solved. Now moving on to number two. They're asking how many hex digits are needed to represent the address of a memory location. So how many bits is an address? 1 2 3 4, 1 2 3 4, 1 2 3 4, 1. I'll just start with 1. So this is a 20-bit address, just as the previous question asked. Now they're asking how many hex digits are needed. Remember this table, I told you that to represent a hex digit represents 4 binary values. So let's group this into groups of 4. Groups of 4. Sorry, it seems I forgot my last values. So now these are into groups of 4. This can be represented by one hex digit. This is not as accurate, but This can be represented by another hex digit. This can be represented as another hex digit. This can be represented as another hex digit because they are in groups of 4. So therefore, we know that you can only use 4 hex digits. You only need 4 hex digits to represent a 20-bit system, bit address. So that's the answer to this question. Now moving on to question number 3. We have, what is the hex address of the 256 memory location? This is very important. Note the first address is always 0. This is very important. Why? The 256 memory location, you'll be tempted to say it is 256, but that's incorrect. Memory location starts from, or rather binary number starts from 0 going up to 256. If you count 0, keep counting till you get to 256, you're going to find out you're going to stop at 255. So, but if you start from 1, you're going to get to 256. So that's why it's very important to note that the first address is always 0. It's very important. So the 256 memory location is actually 255 in value. So what is it now asking? It's asking what's the hex address of this 256 memory location, right? And we know the value of the 256 memory location. So we only have to just convert this value to hex. And if you convert 256 to hex, I believe all you have to do is divide by 16 divided by 255. So because 16 is the base for hex values. So 16 to 255, we're going to have 15 remainder 15. 16 into 15, we're going to have 0 remainder 15. And now in hex, whenever you have values greater than 10, you can see here, you start representing them with alphabets. So where is 15? 15 is represented as F. So here we're going to represent this 15 as F and this 15 as F in base 16. So therefore, this is our final answer for this question. Then for D, it's asking the program is stored in the lowest 2 kilobytes block of memory. Give the start and end address. So first, I need to know the number of bytes in this system. I know 1 kilobyte is equals to 124 bytes. So therefore, 2 kilobytes will be equals to 248 bytes. So now I know the number of bytes in my system. I can now know my memory address. I know my memory address will start from 0, rather, all the way to 247. Since the total is 248, since we're starting from 0, it's going to stop at 247. Remember that tricky kind of questions. So what is 0 in hex? I'm using hex because if I use binary, it's going to be an 11-bit number, and that's okay, but it's quite long. So it's just going to be 0000000. And if you convert this to hex, you're going to get 7FF16. So therefore, this memory location starts from 0 to 7. This is the starting and ending address of this lowest 2 kilobytes. So that is all for today's class. I hope you have understood how to interpret this question and solve it. Thank you for listening.